Hello and welcome back to my workshop. My name is Robert. This video is part 2 in a series on making a replacement gear for a milling head. In this video I'm going to make the mandrel, finish the gear blank, gash the gear blank, put the involute curves on the shaper and finally assemble it in its final location and demonstrate that it actually works. Not everything goes quite to plan, but you'll get to that in a minute. Let's get on with it. Next job is to make an arbor to hold it while I'm cutting the gear. So this section here, this is just over 40 millimeters long. This is just turned down to a suitable diameter to fit in a collet. This diameter here is whatever the stock diameter happens to be. And the gear will then sit on this register here, which is 1 1/8 diameter, with a keyway that will have to be cut in it to make sure it doesn't spin while we're either sawing or shaping the teeth. And this section here I use a 1/2-13 thread because I have 1/2-13 on most of my arbors, so I've got some hardware that will do that. Then all I'll need is a washer, which is a big enough diameter to go right across here so that it will secure the gear in onto the arbor. This dimension here is about 1/10 thou less than the thickness of the gear, so the gear is guaranteed to get trapped between the washer and this shoulder here to make sure it doesn't go anywhere. This is 1.5 E/8. There's about just shade over 4 inches of it, which is just enough to make the arbor out of. I'm going to turn down the first 1 5/8 down to 3/4, clean up all of the surfaces there, and then take the 3-jaw off, put it in a collet, flip this round, then machine the other end. It's about 1 thou under all the way along. That will do very nicely. That will fit in a 19mm collet perfectly. Mounted up in the collet, nice and tight. with you. Right, 13 C7TY. Hello. Time to cut the keyway. I'm going to cut a 5/16 keyway, an 1/8 of an inch deep, and total length of 3/4 of an inch. So, given that if I stuff this up it's going to be a bit unpleasant, I did a trial one first. Turned out very nicely. So we're going to repeat the same process. Plunge in half the depth with this 6mm cutter, walk that along 1/2 inch, plunge for the remaining depth, walk back, then change to this cutter, which is an 8mm one originally, but I've reground it. This is one that I've sharpened, and it measures about 310 or so. It cuts about a 308 keyway. So I then have to move over by 2 thou, go down one side, over by 2 thou the other way, down the other side, and we'll have the keyway correctly cut. This key steel is a nice fit in there. That will make a very secure key with no slop. So I think we'll call that good. So here's the finished arbor. Off camera, I've made a key and I've put 2 flats on to give me something to grip in the vise when I'm tightening up the nut. So now the blanks fit on there very nicely. They're not a loose sloppy fit. The washer goes on and the nut to secure the whole thing, and there's the completed arbor with its 3/4 inch 19mm spigot to grip in the collet chuck. Last operation before starting to cut the teeth. I need to turn the OD of the gear. This needs to be bang on 2.2 inches. Good enough for me. So the first operation in forming the teeth is going to be to gash them to depth with a saw which has approximately the same width as the root of the tooth. This saw is a 3/32. I've measured it in several places and it's coming out around 92 thou thick. The root of the tooth, the width of the tool that I'll be using on the shaper, will be 97 thou. So this is going to remove the bulk of the material at the bottom of the tooth when you get quite a lot of tool contact, a large chip area on the shaper, and it does tend to cause chatter. So removing the bulk of the material helps enormously with that. The way I'm going to proceed here is I'm going to touch the saw on the side here. I've blacked it up so that you'll be able to see the mark nice and clearly. I will then move over by half the diameter and half of the saw thickness, that being 92 thou, so we'll be going over by 46. Once I've moved over that much, I should be bang in the middle. I'll then scratch off a very fine line across the top, which will give me the Z height reference. The whole depth of the tooth is 216 thou. I'm going to take 116 on the first pass and I'll take the balance of 100 thou on the second. There's no key in the arbor, so if anything goes wrong, this can slip. This is the saw that I sharpened in the previous video. Everything is tightened up, relying on the friction here to drive this cutter. So now we'll raise the table. So that's a 0. Between each tooth, all I need to do with this dividing head is to rotate the handle twice. Nice and simple, there's no messing around. It's a 40:1, so 20 teeth is 2 rotations. Let's just set the stop so that it will automatically kick out, so we're not going to go milling straight through the dividing head. And at this point it's cutting so nicely that I'm thinking maybe I should take the full depth in one go. Fortune favours the brave. Fortunately, it looks like it's in the right place. Got 2 more teeth to finish off here. If I line up the 2 gears on the original spindle and you gaze down, you will see that the original gear has been cut just a shade deeper, so I haven't gone too far. That's the positive takeaway from this. So since this was gashed on the mill, the chuck hasn't been undone, so the gear is in the same relationship with the handle as it was before. And this was in the vertical position with the locking pin engaged in the disc. Now the locking pin has to be removed, otherwise the universal shaft does nothing except tries to break the pin. That slot, this slot here now, is vertical because of the positioning of the dividing head, and I have this adjusted so that the tool is right in the middle of the slot, like this. So that tool is now going to straddle the sides of the slot. I've rotated the handle by half of a turn. So if I take that round by half a turn and then use that to run a feeler gauge underneath the tool, six thou fits with a nice drag on it. So there's about 6 thou clearance there. So when I will lower the tool slide 6 thou, and that will be on the 0 mark. Then we can start counting our feed in from there. Okay. Probably could handle 50 thou in one go, certainly at the moment. This might go wrong, but I'm going to try 75 and see whether or not the machine likes that or not. So here we have it, new gear, the old gear, all done, or is it? If I flip them both over and you have a look, you'll notice that this gear, the new one, has different teeth shape than this one. This one I cut with a 14.5 degree pressure angle. This one, it would appear, has got a 20 degree pressure angle. So we have a diametral pitch gear with a 20 degree pressure angle, which was, it's clearly my fault for making an assumption. So fortunately I made 2 blanks, so that one's going to have to be turned into a 20 degree pressure angle gear. Right, enough on setup. I'm going to do this in 50 thou passes. So that will be 4 times around to get to 200 thou, then a 25 thou pass to get to the full depth. Being that this is a 20 degree pressure angle, the full depth is now 2.25 times the diametral pitch, as opposed to 2.157 for a standard DP gear with a 14.5 degree pressure angle. You may have noticed that the locking lever has made a reappearance on the dividing head instead of the plug that I made up. I think part of the reason for the chatter is that tool pressure is causing the dividing head to back off slightly. So, and then as it moves on and on, it eventually ends up with a bigger and bigger and bigger cut, and that's what causes the chatter. So what I've done is to put a very slight drag on the locking lever, which stops it backing off, and it seems to improve the chatter no end. On this pass, the cut has finally reached the bottom of the gash, so it's cutting right across the entire profile of the gap in the teeth. So I think I've got 5 thou left to go. So before I take any more, I'm going to measure the width of the tooth at the pitch diameter. It's just about there. Well, that's the depth. That's actually saying 157. Well, it's the judgment. It's about the same as the finished gear, so the original gear. So I'm not going to take any more off of this. I'm going to call that one good. So change of scene for this. This is the garage where I do my welding. This is the bottom half, I think, of the milling head that this gear is intended for. This is the shaft it sits on. And there's the gear in there. All works very nicely. Ignore the discs of aluminium. They are placeholder bearings. They're just there to avoid having to press bearings on and off. There's another one in here. They're the same idea in OD as the bearings. They just save you having to press bearings on and off and ruin them. Here's a view of the milling head from above. All rotates very nicely. There's a little bit of backlash in there, so it'll keep it running smoothly. So there we go. One gear, correctly made and installed. By the time you see this video, its owner will have it back, and so John, I hope it gives you years of reliable service. If not, you know where to come. So, I still have a 20-tooth 10dp 14.5 degree pressure angle gear. If anybody's got a burning need for one, this one's just going to sit on the shelf otherwise. So until the next video, thanks for watching.